Morning everyone. So we started last class with part 2 experiments and we defined what is called as contrast or effect, so which is nothing but the coefficients, and once I have this contrast defined, then I have this sum square effect, mean square effect, everything fall in place. So we did it for part 2 experiments as well as for part 3, right. So that is what we ended up with, and now the natural step is to, we can define a regression model, and the regression model, the coefficient are nothing but fx divided by 2. So the most important equation is the contrast, and then these two equations, the effect equations. Once I have the effect, everything else falls in place, okay, and the effect is function of the coefficients, which is the contrast, the Ci, okay, and this allowed for replications as well. Remember, we have to do replications, otherwise sum square error degrees of freedom is 0. So these are the key points. And now we slowly move on to what I call 2K design, okay. So part 3 is okay, but then we usually go up to multiple factors at 2 levels. So we have in general k factors, so each with 2 levels. So that is why we call it as 2 power k, and the main effects are a to k, okay. So the k main effects, then second order interaction is kc2, third order interaction is kc3, and the kth order interaction is kck. So these are the interaction terms we are talking about when you scale up to 2 power k. So kc2, kc3 up to kck interactions, and there are k main effects. Clear? You can replace with 4, 5, whatever you want, but this is my general 2 power k design, okay. Each effect has only 1 degree of freedom, which is what we saw, because this is 2 levels and the full model has 2k minus 1 degrees of freedom, error has 2k into n minus 1 degrees of freedom. Error is by subtraction, so this is what the degrees of freedom involves, okay, and the effect is again given by summation in Ci yi divided by 2 power k minus 1. Now you will have to find out the contrast yourself, okay, for each term. So how do I come up with the table? Is there a straightforward way? No, unfortunately. So you have to expand it. Remember, we expanded this for the interaction terms and all the main effects, we have expanded and come up with the contrast table, okay. Unfortunately, I do not have an easy way to define the contrast table, because if you remember, if you know, as k increases, your number of interactions also increases in a combination fashion. So subtraction addition, there is no pattern, okay. So every time you have to come up or know the contrast table, and the good part is it is done only once, like your Gaussian PDF, it is only one does. So for 2 power 4 there is a contrast table, for 2 power 5 there is a contrast table, and etc, okay. So once that contrast term is known, then everything becomes straightforward here, but unfortunately, as I said, the contrast table is not going to be straightforward. Clear? Any questions? So far so good. So these formulas will make sense only if you have the contrast. For 2 power 2 and 2 power 3 we derived it, beyond that it does not make sense to derive, it is better to use a table, already pre-computed or pre-populated table is better, right. For 2 power 2 and 2 power 3 I did it so that you have an idea how it is done. Clear everyone? Okay. So this is the general 2 power k design, nothing big here, nothing difficult here, you are just scaling it up from 2 power 2, 2 power 3 to 2 power k, okay. So what is the next logical step after learning this? Blocking. We did blocking, we did it multiple blocking and so on. Now and then we extended it to 2-way ANOVA. 2-way ANOVA is very, n-way ANOVA is complicated because there are so many levels, so many treatments, it becomes complicated. So for screening purpose we went into factorial experiments, especially at 2 levels, right. Now we did it for 2 factors, 3 factors, k factors. Now we should start thinking about blocks. Okay. The next logical step would be to look at blocks in factorial design. This blocking equally applies to ANOVA as well, 2-way ANOVA as well. Okay. So we have to start looking at blocking, and the key thing is, if I have 10 factors, how many experiments do I have? If I have 10 factors, how many experiments should I need to do? 2 power 10. Can 1024 experiments be affordable for screening? Not really. So you have to figure out what interactions are important, right? You cannot perform 1024. So how many experiments should I perform? How much I can give away? Now you are asking practical. Okay. So far it is idealistic conditions. Now we are going to talk about 2 things. One is blocking, the other one is called confounding. I introduced this term confounding earlier, okay, but in a very brief fashion. So we are going to talk about confounding and blocking. That is the next step, we will take it up.